Okay, so good morning, afternoon, and evening to all our data enthusiasts. Very warm welcome to today's webinar on data migration. I am delighted to have all of you join us from different corners of the world. So when we talk about data migration, we know, that it plays a vital role in today's ever-evolving digital landscape. As organizations continue to grow, adopt new technologies, or undergo digital transformations, the need to efficiently and securely transfer data from one system or platform to another has become increasingly important. Whether it's moving data to cloud or updating to a new software solution or consolidating information from various sources, data migration is critical and that can significantly impact business operations and outcomes. Introducing our exceptional speaker for today's webinar, we have Pavan, who is a renowned data engineer at Microsoft. Pavan comes with a degree in information technology, wins across multiple hackathons, and roughly 8 years of work experience in data engineering. Pavan has also worked at companies like Infosys, ADP, Altimetric, and he has a wealth of knowledge and practical insights that will undoubtedly enrich our understanding of data migration. So on today's webinar, what we will be covering, or what Pavan will be covering, is importance of data migration process overview, some challenges, best practices. We'd also touch upon data security, compliance, monitoring, and post-migration considerations. So we would actively, we encourage you to actively participate, ask questions towards the end of the session. So once again, I'd extend a warm welcome to all our attendees, and we're excited to have you join us on this data migration journey. But before we dive into the world of data migration and explore the strategies, I'd request all of you to devote a few minutes in answering this particular poll. I will be putting it on chat. Yeah, I've just attached a link to a doc. We'd be grateful if you could fill in your information just so that we know what kind of audience we are sort of tackling. And yeah, just a few minutes, just 1 or 2 minutes, and then and then over to Pavan. Pavan, could you see the doc on the chat? Hello?
Sorry, I was talking on mute.
Oh, sorry.
Yeah, I can see the link.
Okay. Okay, great. Okay,
Yeah, I can access that too.
great. Okay, we'll maybe just give it another minute, wouldn't take too long, and then great to know that we have a full-fledged audience that's set aside some time on Saturday to enlighten themselves about data migration. And okay, you can go ahead and continue filling in. All right. Meanwhile, Pavan can start off as well. Over to you. Over the stages, all yours. Virtual stages, all yours, Pavan.
Thanks, Radha, for a lovely introduction. And I see the enthusiasm from the participants who already shared few of their thoughts. So I try to cover, uh, you know, all the basics at least in the data migration, because it's a huge topic, and the data migration varies from requirement to requirement. So I try to put all the generic information which should apply everywhere. But yeah, let's start this up. So in this webinar, I'm going to cover the importance and the benefits of the data migration, and various approaches we often take to complete a successful data migration from on-premise to cloud. In this next 30 40 minutes, I refer to the migration from on-premise to cloud, but this is a generic process. So even from cloud to cloud, you can follow the same procedure with minimal differences. But yeah, this is a generic one I try to put up. And I'll also explain the various roles in a team which leads to the successful data migration, and how we can prepare before we actually implement the data migration project, and common challenges and best practices involved, and what is the importance of security and various compliances we go through in different locations, and what is the significance of monitoring, and how we make sure this is done successfully, and what are the metrics, are what are the basic tests we need to do. So this is the data migration basics I'm going to cover, and then we can explore some activity for you to do the data migration process and practice by yourself. And I'll also walk you through the awesome Project Pro as a platform, and then you can go ahead and ask your questions, and I try to answer all of your questions. So that is a agenda for this night. Um, so with that, uh, so why actually we need to do the data migration? What factors tend an organization to do this data migration? So we can broadly uh, differentiate or group the triggers into two things. Like one is actual migration needs, and also the project structuring based on that we are going to do the data migration. So these different triggers, like migration trigger, for suppose uh, an existing an organization already have some bond with existing third party data center, and that agreement is expiring. In that case, it opens the door to think of data migration from on premise to the cloud. So in this case, people generally tend to migrate or put up the data from their third-party vendors data center to public clouds like Azure, AWS, or GCP, and other clouds. And if organization has any cash flow challenges, so earlier organizations used to spend a lot of money in the acquiring different services, or prepare hardware, buy hardware, and set up their infrastructure for future needs. So instead of put expenditures for the capital, so capex is a capital expenditure, and OPEX is the operational expenditure. So CapEx means you are going to spend your a lot of money to set up your infrastructure, whereas OPEX is clouds coming into the picture. You pay as you go. So whatever you are going to use, you are going to pay for only that particular service at that particular time. You are not investing any cash for your future needs. So which is a good thing for an organization to maintain their cash flows. And in case of any cyber securities, because we are going to maintain our infrastructure by ourselves, and we might not have a good security firewalls, or some networking, strong networking, we might see some cyber threats, and which leads to data breaches, or personal customer information breach and stuff. In such cases also, people or organizations tend to do the migration from on-premise to the cloud, because cloud has its defined the security, and how to avoid the data breach, and they also come with some compliances, so that is easier for any organization to adapt quickly. And for business continuity, for suppose there are any natural calamities happen during that time, the particular data center may be down for some time to recover from the disasters. So in that case, to avoid any such natural disasters or the calamities, we can go to cloud, because cloud will offer you a multiple different zones, and you will have multiple different availability zones. For suppose, you can have data centers across the world, and you can choose one availability zone in one particular data center, and another availability zone from another data center. So if some natural disaster happen to one data center, you always have the backup from another data center. So in this case, your business is not going to pause or stop for some time until the situation recovers, because you already have the backup in another availability zone. So you just switch to the backup data center, and you need not to worry about this backup also, because that is already automated. Whatever data you have, you are going to replicate that in different availability zones. So when you are trying to create any service, you are going to opt for different availability zones to address such natural disasters. And also this having data across different global locations will also give you the performance benefit. So for suppose, we are in India, and one of our organizations are servers are hosted in Singapore, than having a data center in Mumbai is always better than having a data center in Singapore. So in such situations, also people tend to opt for cloud migration. And so this have opting for cloud will also give you a rapid scale and application scale of applications and infrastructure. For suppose, let's take an e-commerce website like Amazon or Flipkart or something like that. In such cases, for in any holiday seasons or festival seasons or something like that, the traffic will be at its peak. So in that case, if we want to scale our existing on-premise infrastructure, will take a long time, and it will be a costly one, because after a few days or a few hours, sometimes you need to bring down the resources to save your money. So this is a process overhead, which can be reduced by opting or migrating your on-premise data to your cloud part vendor. So in such situations, it will give you a rapid scale. For suppose, let's take an example of uh, a Databricks cluster. So in few scenarios where we want to process 100 TBs of data, and that is not the case every day. So in general cases, you are going to uh, select one medium cluster, or a minimum cluster, and when there is a need, you can upscale that to a large cluster, or extra large cluster or something like that. And then you can downscale that by just changing the configurations inside your environment. Whereas in on-premise, this is not that easy. And application innovations, as all the cloud providers come with your machine learning capabilities already there in the environment, so you can readily use them for your organization's growth. And sometimes people who wants to transform their environment or infrastructure from existing on-premise environment to modernize their platform, or transform their infrastructure in digital manner. In that case also, people tend to migrate to cloud based services. And the benefit of this migration would be faster time to market. For suppose we want to launch a product within no time, keeping that in the mind from your competitors maybe. So in that situations, so many services are already pre-made and available in your cloud resources. So in that case, the uh, deployment or the releases are quicker than compared to your on-premise go lives. This also enable remote working because of some unwanted changes like COVID we had. So from the situation, everybody is moving towards working from home or hybrid or at least non-workspaces. We are working currently. So in this case, this cloud will give you so much flexibility. So you won't believe, sometimes I write some Databricks code while I'm in my bus from office to home or home to office. So in my mobile itself. So my infrastructure is in cloud. It gives me a flexibility to write code from anywhere and any situation. Even I can use my mobile or tab, or it doesn't matter which device you have. You have internet and you can work from anywhere. So this is the real flexibility which you get from migrating your on-premise infrastructure to cloud-based infrastructure. So then, what are the benefits of doing so? As I just mentioned, it enables, or it will increase the accessibility to your infrastructure. You can work from anywhere, you can access anything. Of course, we also might get some questions like, what about the security? uh, all the clouds are in such designed in such a way, only there are particular authorizations are required using some multi-factor authentication or something like that. And every user will have their own IAM roles and stuff. So using these security measurements, we can access our cloud or our applications from anywhere. So this increases the accessibility and also improve the performance and agility. So using cloud will give you upscaling and downscaling your services immediately with some configuration changes, and you need not to worry about anything else. It will improve your productivity, and in an agile manner you can change any infrastructure within no time. For suppose you want to try out some new scheduling tool. For suppose you have an ADF, or Azure data factory for your scheduling purposes, and you want to try out a cheaper options like Airflow. You can do it easily without setting up your environment by yourself, because you already have that in the cloud providers like AWS or Azure. You can even do, for suppose let's take the same example. You are scheduling your jobs using ADF, as you have opted for Azure cloud. But you want to try out managed Azure managed workflows for Apache Airflow from AWS. You can still do this cross domain, or cross cloud platforms. You can have all your data in your Azure, and you can access that Azure from your AWS MWA also. So that is also possible. In that manner, you are also uh, supporting uh, the innovation in your organization. You can choose anything which suits your setup, and it is not so much costly. So in that case, you are optimizing your costs also. So you choose something better in one cloud and something else from another cloud also. That is also possible. And the elasticity, like I mentioned, in season based on the seasons, you can increase your clusters and decrease your clusters based on the traffic maybe, or you can define during some peak hours in a day you are going to need a big a cluster, and otherwise you are going to the normal cluster. So that is also possible. Uh, you can maintain different sizes of the clusters in different times of a day. That is also possible using your cloud. And because of all these things, that you are optimizing your resources, you are going to upscale where necessary and downscale otherwise, and you can even shut down few services which are not needed. For suppose during weekends you might not need the data warehouses or the Spark clusters to run at least in your lower environments like development or U8 environments or PP environments. So in that case, you can schedule a job to shut down all the services during weekends. So this is very much possible, and it's easier to set up your jobs to shut down. This way, you are also optimizing your costs and you are achieving the cost efficiency also. And you are getting a huge support from all these cloud gains like AWS, Azure, and GCP. The security and the compliances. So I'll deep dive to security and compliances in a while, but you get all different security protocols. You will have Azure you know excuse access directory, active directory to maintain your user IDs safely, and you can do a multi-factor authorization or authentication to log into your application. So this everything is possible, and it is already there in the cloud, so you need not to worry about inventing the wheel again. So this is easier journey with the cloud. So then I'll dive into the data migration process. So there are multiple various approaches. So we can directly lift and shift your applications or your data from on-premise to cloud. So that is just a rehosting of your applications. For suppose in your on-premise you have hosted a web application, let's say. So that web application is hosted in one virtual machine, which is in some third-party data center, and you want to migrate it to another cloud-based solution. So you are just going to have everything as is with respect to your application, but you just going to change that virtual machine. So you are going to acquire that virtual machine in your cloud provider, and you host everything, every other feature as is from your on-premise data center. So that actually reduces your capital expenses and free up the data center space, and you also achieve the return on investment rapidly when you use a cloud. So there are different approaches, as I mentioned. People also do some minimal changes to optimize it for applications with respect to the cloud, using some infrastructure as your service or platform as your service environment. So in that case, you are going to write few lines of code, or you just modernize or revamp your applications with respect to the cloud provider, and then you host in the cloud. So it is it involves some modification to your existing code, but not much. So doing this refactoring of your applications will give you faster and shorter updates, so you don't spend much time. Within very less time, you can refactor your existing application and host it in your cloud, and you achieve some code portability. For suppose you use some RDS in AWS and you already have your data in let's say MySQL. So in this case, you need not to change much with respect to your sequels, because the sequel which is there in on-premise environment and the MySQL you are selecting from RDS are the same thing. So you need not to worry much about syntax or data types or anything in this case. You just lift and shift your data, and for suppose you want to change your scheduling process, maybe in your previous on-premise you are using some Xena for your scheduling, but in this case you want to use Airflow or any other feasible scheduling tools. So in this case you are just going to change your the way you used to schedule your SQL procedures or any other jobs you are actually using. You are just trying to migrate yeah, all the data as is, but only change the scheduling tool in this case. So in that situation, you only end up writing code for your job schedules. Everything else will be the same thing. Uh, and the third one is re-architecting. So re-architecting means you are going to uh, change your architecture in a way that modernize your infrastructure or the environment completely. For suppose you are using MySQL database, but for your use case, you see you need a modern data warehouse on cloud. Well, and let's say you are opting Snowflake for that. So in this kind of migrations, you are going to re-architect, you are going to replace your existing tools and technologies with the modern tools and technologies in the cloud. As an example, MySQL to Snowflake migration. So in this case, you are going to look after the schema changes or the data type changes and how you can better get the optimized solution in Snowflake, and check whether you also having some unnecessary tables or schemas in your existing environment, and you are going to reduce the overheads which are no more needed in the modern architecture. So in this case you are going to pay attention on getting the most out of this migration. So this needs more planning than previous two approaches. So this will give you the agility and scalability as you are completely modernizing your applications. You are replacing existing tools with new and modern era tools or technologies. You can, as I mentioned, you can use mix of all the technologies or different ways of making it optimum for your use case. You can adopt easily all the cloud capabilities. So re-architecting also easier comparatively what you can do on premise, but it is little bit time taking and needs attention to details when compared to rehosting or the refactoring of existing infrastructure. So then comes the rebuilding. So it it actually uh, refer to uh, developing your application from the scratch. So you also tend to change some business functionality also, because you already have the same infrastructure from ages and you want to do some changes with respect to the cloud. In this case, you are going to build everything from the scratch. Not sometimes we don't even leverage existing scripts also, but based on the use case, you can leverage existing scripts to rebuild your completely new or scratch environment. So this also, when you decide this needs to be done, cloud will help you to accelerate your application design or development, and it also reduces the operational cost. So when we compare rehosting, rehosting, if you are spending for suppose $100 in on-premise, and when you just change the VM to cloud, I don't think you are going to save much in with respect to this, except the availability and the features you are going to get. But when you rebuild your application with respect to cloud, there is a high chance that you are going to save a lot of money when compared to just rehosting your application in our cloud. And you can also replace your various services with the SaaS applications which you can host in cloud. It is pretty much similar to the rebuilding or the architecting your advantages of opting your cloud problem. Uh, and then as we choose our approach to data migrate from your on-premise to cloud, now we can discuss about the team or all the expertise we need to have in a team to do this application migration successfully, or data migration successfully. So in agile or scrum method or agile methodology, there will be different stakeholders. Let's if I start from business owner or the product owner who knows or owns all the data products and everything, who has a very good knowledge about these business and who can explain everything, um, and who has very good knowledge about the environment. So that we call business owner of the environment. He is the key. Uh, uh, he is the key member of the team who takes care of all the requirements and who can explain to different stakeholders like architects or data engineers for that manner in a better way to get the most out of this migration. And a project manager who coordinates and often behave or take the role of scrum master in the project, who coordinates with all the different teams like data engineers or testing engineers or the business analysts, and group everyone to uh, track the progress and try to unblock different individuals in further manner. um, and a cloud engineer, yes, as we are migrating to cloud, it is beneficial to have some at least one cloud engineer who has vast knowledge and experience handling these kind of cloud migrations, or at least know all the different cloud services. It will be beneficial. And then a database administrator, I think in this case, when we already have our data in on-premise, we might already have maintaining or having a data administrator. That data administrator should be active in this team, so that we can ask different questions while doing the migration, and he would be very much helpful here. She would be very much helpful doing this migration. And the data modelers, before we actually implement our data migration, these data modelers knowledge is must, and that will solve so many problems. For suppose, if we don't have any a better data model, we don't know what is already existing and how we can remodernize or revamp to the latest uh, data warehouse per se. So in that case, data modelers design how the table structure should be, what is the logical and physical data model, and how we can associate one object with another object. For suppose, we used to have ER diagrams which actually explains the relation between two objects in the data lake, or data warehouse for that matter, in legacy systems. So these data modeler will define the relations, and and explain how better we can design our data flows in the latest architecture in the cloud environment. So we can make sure not only adhering to existing business requirements, we can also revamp according to the cloud offerings. So in this case, data modelers come handy, and it will be very much helpful if we have a solid data models already available. And of course, we need ETL developers who can extract data from existing um, data warehouse or data lake, and transform based on the business requirements, and also load it into the target uh, systems. So these developers need to work under some architects or cloud engineers who already have a very good experience and working knowledge on the cloud. So then we also need some virtualization specialist. So the basic concept of virtualization is nothing but we are not going to duplicate the data in different environments. For suppose in legacy systems, we have the data in at least three different environments: development, UAT or QA, and then production. So for all these environments, we are going to duplicate this data for different manipulation. In some situations, we don't want to expose our production data in lower environments. In that case, also we end up creating the same objects in these three uh, environments. So using virtualization, we can save the space and processing, and this encapsulates the data in different environments, and it will avoid creating copies of data in these three environments. For suppose if we have our data in production, using virtualization technique, we need not to duplicate the data but manipulate in U8, untouching the actual underlying data in production. So this is the advantage of doing data virtualization. For suppose there are multiple tools doing virtualization. One of them is Denado. You can explore Denado, and it will be interesting for you to explore that. I don't see organizations are opting for data virtualization in a general way, but it is very much beneficial. If we use data virtualization, we save a lot of data and also processing. And of course, we need to have a testing engineer who helps us making sure existing functionality is intact and we are not losing anything. So test engineers will work on testing plans as ETL developers do the ETL work in during the migration. And once that is done, testing engineers comes into the picture and do the testing, application testing in different levels. And business analysts, where we have our uh, uh, BI needs, like we are going to present our data in the uh, Power BI script thing, maybe uh, charts or any visualization needs. In that case, we need business analysts, and we are going to leverage them if we are trying to change our business to BI tool also. In many of the cases where I worked, we untouched the Power BI reports, or all these analysis part, and we try to put everything just before the visualization, so that we we don't spend much time on migrating this, because we already had the latest BI tools, for suppose Power BI or ClickSense. So that is enough for us to represent the data in a better manner. So I mean, it again depends on the use case and organization. So based on the requirement, these roles may be done by one person. Multiple roles out of these roles may be taken by one person, or if the project is huge and we have enough resources, individual will play a different role in the team. It completely based on the organization requirements and the availability of resources. uh, and coming to the preparation, so first, to make any data migration process project successful, we need to have a solid plan. As part of the plan, we need to define the scope of migration. In case of a huge organization, we might have multiple data marts or multiple disparate data sets, having vast footprint in different technologies. Like we might have some unstructured data, we have structured data, we have semi-structured data, and to have a different data needs. So for in that matter, if we try to migrate everything at once, we might not able to do that. So we should have a plan to do the migration in a manner, in the manner such that we do it slowly and take one part at a time, and we progressively complete all the migrations of all the objects available for this business. So for that, we need to define the scope by which time we are going to finish this migration. So we will declare the targets, and we commit to that particular thing, maybe using, if most of the organizations are using agile methodology. So in the agile methodology, let's take a scrum approach, and we are going to create epics, features, and PBAs. So PBAs coming to our, the user stories are going to come in the sprint, and a feature is a mix. A feature will contain multiple user stories, and multiple features will farm an epic. So in this manner, every product manager, besides product owner, define the goals. Nothing but the features and the epics they are going to define. And further in the scrums, we are going to break down each and every user story, each and every feature into user stories. This user story will have a commit date of a sprint, or 2 week sprint, or a 3 week sprint. So yeah, this is coming under agile methodologies and a scrum team. So basically, we before we do start any implementation of migration, we need to define all these the scope of the migration using Jira dashboard or ADO or any such tool to track the progress of do the planning, and also tracking where we are so far. So that is how we need to define the scope for this particular migration, and we divide that into logical blocks of the objects we already have. And of course, we need to upskill existing developers. If not, we are going to hire a talent that already have experience working on the cloud technologies or the new technology we are trying to move on to. So generally, as we are moving to cloud is very much developer friendly. It actually had to do only the configuration part, and the coding will be a little bit if not a hard one, it is comparatively easier to existing days. You will have all the documentation itself while you create some resources then and there. So upscaling is not so hard these days, as we are moving to cloud. Everything is readily available, and we can just take it and look at it, understand, and take it forward. So but we need to invest some time to scale up and train the existing team to do this migration. And before we actually implement this, we need to work on some POC and see how the new environment working to understand how better we can adopt the new environment to do this migration. And before we move further and implement, we need to categorize different data sources we have. For suppose we might have RDBMS and NoSQL databases, and a JSON file, Excel file, or flat file. So different files will be there, and different in the different locations, and we might need to ingest the data using different tools. So we need to define that for the sake of easy migration. I would recommend to define a particular tool for a particular use. For suppose I want to get data from APIs, and then I only decide to read the data from different APIs using NiFi maybe. So that is an ingestion tool. So I'm going to strictly use NiFi whenever there is a requirement to read data from APIs. So that is how I define different tools for different purpose. Maybe for data processing, I'm going to use only Databricks or Azure Synapse. And for my storage, I'm going to use only Azure Blobs. So whatever data I'm going to get, I'm going to store the data in Azure Blob and then do the processing. Or for my end data warehousing solution, I might use Snowflake or any RDS from AWS. So I'm going to define for any tabular formats, I'm going to use MySQL in RDBMS or PostgreSQL in RDS. So like that, I'm going to define different uh, data and access accordingly. And while we do this exercise, how many different sources are there, that will give me an advantage to develop configurable and reusable components. For suppose I have a JSON file, I have a plain file, and I have a Parquet file. So for these three, if I don't have any reusable or configurable components, I need to write code multiple times which does the same thing. So we are just reading the data from our source, but our the format is different. The only format is different. So in this case, when I write a reusable component which can be configured, I need not to write my code. Let's say I'm going to read a Parquet file, a JSON file, and text file using a Spark-based application like Databricks. So in this case, what I do, I'll write reusable components in such a way. If I give an input configuration, it will trigger the respected code. For suppose in my, I'll pass a JSON file to my Spark application in such a way. If I mention my source file is in JSON format, or my source is in Parquet format, using that data type, my Python script will use spark.read.parquet. So that is to read data from Parquet in Spark. So if I mention my source as Parquet, I'm going to read using spark.read.parquet. If my configuration file has file format as JSON, I'm going to hit spark.read.json. And if I need some schema, I'm going to pass it using a file, a specific file or something like that in the configuration file, and I'm going to pass it to my Spark application. So this way, I'm going to configure the Spark application, but I'm not rewriting the code every time. So this way, I'm going to reduce a lot of time in this migration. So we need to group the data and write configurable and reusable components accordingly. And we are going to uh, uh, take, as I mentioned, we are not going to do the complete migration, but take a particular uh, uh, data mart for this case, and I'm going to do a POC on top of that. And after that, if the POC is successful, then I take another data mart and do the migration. So this will be a iterative process. I'll not going to do the data migration at once. So then also as part of the preparation, we are going to establish connectivity between my on-premise and cloud systems. So for suppose if I need to read data from any on-premise data lake, I'm going to create one linked service in Azure. Using that linked service, I can access my on-premise data. And also, I need to decide on CI/CD part whether I already have some Jenkins script, maybe. So in that case, I am going to stick with Jenkins, or is it any better if I go with some YAML based, you know, thing or existing is fine. So that also I am going to decide the where I can store my code, whether it is in Git or Azure DevOps or GitLab or GitHub, various things I'm going to consider and plan for the same. And of course, in this cloud, the advantage compared to on-premise is whenever I'm going to use a new tool, or for suppose I'm going to create one resource in development, to replicate the same thing, I need to do the same configuration again in my U8 environment. But coming as we have infrastructure as code tools, we can reduce this thing. We can generalize one script where I going to define creation of one particular tool. I can reuse the same thing by changing some environment variables to create the same kind of resource in my other environment. So I'm going to create some a Databricks cluster, let's take as an example. So I can write my code in Terraform, or AWS cloud formation script or something like that. I can just change the environment variables and create the same cluster by running the same script for U8. So this way I'm not going to repeat the same thing again, even to create the resources. So this is the best advantage if you use infrastructure as code tools like Terraform or cloud formation tools in AWS. And finally, you also need to define the test strategy, whether you are going to um, check row by row or the data level thing, like you are going to compare apple to apple kind of thing, like you have 40 fields and you are going to check the 40 fields are matching with this. Maybe you can ignore some, excuse me, extraction dates or something like that, and rest of all the fields you are going to compare your existing tables and after migration table, before and after. Or you can use some checksums like MDM5 or SHA 32 or 62 algorithms to define a file level or table level or row level. So using these checksums, you can compare before and after data migration whether these checksums are same. So like that, you can define all your test cases and run them after once you successfully done the data migration. So this is a basic migration preparation any team needs to do. And while doing this migration, we might generally see some challenges. For suppose we will have different uh, uh, data types in different data warehouses. For suppose if you take SQL Server, you might see bit as a data type, but you won't find that in your Snowflake. So in that case, you need to map this bit to a Boolean or something like that. In for that matter, the data types, you are going to redefine that. So in this case, if while I'm talking about SQL Server and Snowflake, there are few Git repositories where you can easily convert existing ANSI based SQL like SQL Server SQL scripts to Snowflake based SQL scripts. So you can leverage that. So invest your time before actually implementing the project. Invest some time wherever you can reduce the efforts and leverage existing tools or technologies already available in the market. So there are so many free tools also available to do this kind of translation from SQL Server SQL to Snowflake SnowQL. So this way you don't spend much time on repetitive work. You can easily bypass that and take advantage of time and spend more time on improving your business logics and stuff. And the major challenge is transfer of the data. If you have huge data in your uh, on-premise or data warehouse or data lake, it is challenging for you to transfer the whole data in a particular time. For that, you can do a few things like you can define what kind of data you are going to transfer first, and what is the pace for that. Suppose we have our snapshot tables and also historical data. So in partitions maybe. So what I do, I will migrate the snapshot tables first, and then slowly I'll migrate all my historical tables, or maybe based on days. So you know how your business works. If you want your data for last 1 week, you are going to migrate only last 1 week of data to on cloud, to cloud, and then once you set up everything for that week, then you migrate the data, all other data from your on-premise to cloud. So this is how you can define the scope for every day or every week, or even for hour. You can define the scope and accordingly you can transfer. And also before we would do anything, do some data profiling of your data, whether you have any duplicates in the data. So if you have duplicates, it is advised to remove those duplicates or unnecessary data. And so it's waste of time and money to transfer duplicate data from your on-premise to cloud, right? So in that case, you can dedupe the data and then migrate the data. Or while migrating itself, you write your ingestion scripts in such a way you avoid all the duplicates. You only get latest data, maybe using some ranking functions, or group by functions or something like that. You can pick up only the latest rows and not the duplicated rows. So uh, using that, if you do the data profiling correctly, you will find all these gaps, the duplicate data or any unnecessary data. So all these things you can find out while you do the data profiling of your production database or whatever database you are trying to migrate to. So do that before we implement the migration. And we also need to take care of data consistency and the integrity while we migrate. So we might lose some data packets because of some network issues and stuff. So in that case, we need to make sure the data is consistent between these two systems. So we need to come up with some design. We are going to, for suppose, whenever we are sending a data, it is as advised to send a metadata file with that particular file. So when I say metadata, while I'm going to send or ingest the data to my target system, I'm also going to give how much data I sent in this particular transfer. So if I if I ingest 100 rows of data to my target system, besides the data, I'm also going to give how much data I'm transferring. So in the metadata file, I'm going to give how many rows, number of rows are being transferred, and what is the schema at list. So in that case, I am going to read the data using that particular schema, and also before I actually ingest the data or the consume the data, I'm going to check whether I really received 100 rows of data. Otherwise, I'm going to retrigger my I'm going to ask my upstream to retrigger the database, retrigger the ingestion, and see how it is happening. So this is about the data consistency and integrity. And also, while we transfer, we also need to zip the data, uh, uh, excuse me, to compress the data using some zip or something like that, and then transfer, so that we are going to optimize our space, and also the compact the data, the faster the data transformation. Then we also need to communicate the downtime and disruption to the downstreams or the stakeholders, to mention so and so time with the service is going to be down, and then it will be up, so that they can wait for the up time, and then do the their processing as usual. And it is better to avoid completely making the on-premise service down, and then do the migration. But once we do the migration and compare the data transformation correctly, then only it is advised to retire existing application. Otherwise, we will have any plan B or rollback strategy. So it is very much advisable to have a backup plan and the rollback strategies. So if the migration didn't happen as expected, we can go back to existed uh, uh, existing data, and do the rollback strategies. And also we need to monitor the performance optimization, how this is happening. And we also need to, as I mentioned, we need to communicate this change to the stakeholders, so that they get all the updates, and they will wait for the migration to be happened, and then take their job forward. So these are the common challenges and the best practices. And while doing this migration, we also need to take care of the data security and the compliance. For suppose any bank related things, or health related sectors, they need to maintain the security or the privacy of their customers, and the health data of their uh, patients. So for that, we need to enforce some compliances, like HIPAA or GDPR or ISO standards, and all different compliance certifications we need to have. So all these are already enforced, or maintained by cloud providers. So it is easier to maintain the data security using identity and access management, and the Azure Active Directory using multi-factor authentication and stuff. And also, while we do the migration, it is advised to have the data encryption while in the while the data is in transformation, or in on the way from one end to another end, and after data migrated successfully to the target database also. So this way, we safeguard any security threats or breaches against our data. So we also get advantage of key vaults in different clouds. so that any sensitive data like passwords or credentials can be stored in the key vaults, and using some key names and stuff, we can access those passwords or credentials using the key vaults. And we also need to monitor the data migration, and we need to maintain the logs, how the data migration happening and how the applications are reacting. So for that, like we need to detect the errors, and you by detecting errors itself, we can have some resolutions, and we also can do some performance optimization, right? For that, we need to maintain some audit trails, and also we need to have some contingency plans using these logs. To maintain this log, cloud offers application insights in Azure or log analytics, or CloudWatch in AWS, and step functions in AWS. So this is a kind of logs and monitoring process we need to maintain every time, or for any application, it's advised to have some logs, how the process is happening. um, so with this thing, I almost covered the basics of migration, various aspects to that particular on-premise to cloud migration. So then we can explore some activity. So Shraddha will share this PPT, and you can explore these two migrations. In case you don't have license to create Oracle, you can simply replace Oracle with your MySQL, free version of MySQL database, and then try to migrate it to Azure. Or another migration is from Apache Scoop to Azure. In this, you can leverage Scoop to do the migration to Azure using Azure Data Factory. And for Scoop related projects, you can search in the um, Project Pro platform itself for real-time analysis and stuff. You can get the basics. So then you can explore Project Pro as a platform and get different migration projects in there. There is already a well-defined migration process available in this link, and also you can expect a new MySQL to Snowflake data migration in like 2 to 3 weeks in the platform. So explore these projects and get most out of it. So with this, I'm open for any questions. Shraddha, do you see anyone having any questions in the chat? I think I have some questions.
Yes, there's Alim who says, as a non-I with a non-IT background, how can I move to data migration? How can I build a career in data migration?
Yeah, so data migration is as part of data engineering, as I mentioned earlier. So for data engineering, you should have a solid SQL background, uh, and at least one programming language, let's say Python, and understand the distributed computing fundamentals, and get familiar with Spark application, so that you can even expand your knowledge to work on Databricks and Synapse tool, Alim. So SQL, Python, or any object-oriented language, and distributed computing like Spark. So these three are the major things, if I would say, and take it from there to understand different databases like RDBMS and NoSQL database, let's say HBase for that matter, or explore different options. So, but basic building blocks, I would say Python, SQL, and Spark. Hope that answers your question. Mm, George, you put some question, but I don't see a question over there.
Yeah, so he
Okay.
says, how will you give an estimate to a migration project Is there any standard estimation techniques for migration, or does it or it just depends on volume of data? Please provide inputs on the estimation part.
Yes. So it purely depends on the volume of data. Even before volume of data, I would say number of objects and the variety of data you get. So it would be for per se, if you already have integration between your upstream and downstream, then it will be comparatively less time. But if you want to create or establish this connectivity, it takes some time because of all the approvals you need to get from your administrator, and then you do the connection establishment, but then you plan, right? So based on the number of objects and the variety of data, you can come up with some estimations. At least I don't have a formula or a template as such, but it purely depends on the time responsive time response time from your administrator and the disparate data sets you have. If it is simple thing, I think for an object you can take some 2 to 3 days, having some buffer time for migration. So at least on an average, like you can have 2 days for per an object from your dev to production environment. So but it will not be that smooth, right? So there will be many hurdles, or you figure out the challenges during your implementation time. So it basically depends on the data and the type of data you have and how responsive your admins are. So yeah, it depends on various factors, Godwin.
Okay, Goodwin, please let us know if that answers your question. We have Ayush asking you the difference between rebuild and re-architect as mentioned in the presentation.
So these are the same similar things. So rebuilding is nothing but you are going to have you are going to what do you say, redesign your business functionality. Maybe you start from the scratch, you define your functional business requirements, and then you start from the scratch and re-architect. You are just going to replace your existing tools. For suppose I mentioned you already have Oracle database, but now you are going to replace that Oracle database with your Snowflake database. So that is just replacing the technology, but you are not changing the existing functionality, right? So rebuilding, you are actually going to rebuild complete application besides the technology. In re-architecting, you are only going to change your technology stack, like MySQL to Snowflake or Oracle to Snowflake or something like that. So that is a basic difference. But yeah, I mean, these are the different names. I just mentioned it for your knowledge. These are the different approaches, but we do some hybrid approaches also. We do this and we do that for based on our requirements. Basically, it's not a strict definition, or you only need to do that. But it all depends on the organization you are working for and the data you have. I hope that answers your question, Aish.
Okay. Meanwhile, okay, Ahmad says, what is the best strategy for testing and validating data migration? And what options to auto fix issues and data missing?
Yeah, so best strategy would be so with my experience in my previous projects, what we did, we can say the apple to apple comparison. So we had our production database up and running till we say we successfully done our migration in the cloud platform. For suppose we had a SQL Server as our on-premise database, and we are migrating that to Snowflake. So once we finish our implementation, then we did this comparison with our existing production database. We for small tables are the what do you say, the dimension tables and stuff, which data is not very frequently changed. For that matter, we created some checksum at table level, and for files we create a checksums at file. And in the same way, we have also compared the same files and the tables in Snowflake using the checksums. And for other fact tables, we accept some timestamp fields and stuff, audit fields. Every other fact field is compared against the existing production table. So that way we maintaining the same data everywhere. And how to auto fix the issues, I think. So now, or maybe using some, auto co-pilots, are, because of ChatGPT revolutionizing the whole industry. You can expect some large learning models helping you to fix the data missing and auto fix that. Or you just need to do, if you don't have the machine learning models or co-pilots available, you need to figure out these issues while you do the data profiling. So exactly for this purposes, I suggested you to do the data profiling. So whether duplicates are there in the existing data, or there are any gaps in the data. So all this will be known if you do the data profiling. So if you do the solid data profiling, you will figure out all the issues then and there. And then you can figure out if something null, some unwanted data is there, you can replace that with nulls. Or based on the data requirements, you can fill those gaps.
Okay, we have another question from Osama, and he says, can we test a data migration process on a platform? And what platforms give us the opportunity to test that?
So when you say migration process and platform test, so what kind of test you mean to say? So I just mentioned, right? So it's better to check the existing versus after migration data. So that is the best option. So testing frameworks, for suppose if you want to do the test set code level, you better write unit test cases and then do the integration test and other uh, uh, data comparisons that you can do. If it is file, you can use some file explorer, and you can compare the files. And for the data, you can write some simple Python, what do you say, Python scripts, and run the scripts against your source and target tables. So Python is the best tool, I would say. It is very much in control. And if there are any tools, at least in my experience, I didn't use specific test tool to compare this data, but I mostly use Python to write scripts and do the comparison. And my testing team also did the same thing, using Python scripts and compare it. So Python is, or any programming language for that matter, is the best tool to do these comparisons.
Great, great. Our last question for today. Harita says, a career path moving into data engineering and a data analyst role, which is less challenging and which is the best career path for the future? Do data analyst jobs, are they going to be in the future, or are they going to be existent in the future, and what tech needs to be learned for this?
Yeah, so that's a good question. So data analyst, for that matter, if you are considering business intelligence, and you are going to use that as part of your data analyst role, then yes. But pure data analysis may be replaced by LLMs in the future. Like when I say LLMs, based on the ChatGPT and other things, these jobs can be replaced. So to future proof your career, I would recommend you to take a data engineering path. Because whatever automations are happening, data engineering will have its own place to find out the gaps in the data per se, or how you can modernize your data, and how better insights you can provide by transforming and cleaning your data. So these are all will still remain for some time, until at least the AI evolve to that extent that no human being is needed to do this data engineering stuff. So in my personal opinion, I would recommend you to take up distribution computing concepts and SQL for the basics, and try to go into a data engineering path rather than data analyst. So once you get all the SQL and data engineering concepts, it is pretty much easy for you to take up a data analyst job also. So if you just add a Power BI or ClickSense or some BI tool into your resume, I think you can pretty well do a data analyst job as well. So it is not that hard to get into a data analyst. So yeah.
Okay then. All right, that is it for today. We will be sending you the presentation as well as the recording um, on an email. And if there are any questions, feel free to drop an email to. I'll just type in my email address. Yeah, it's on the. Sorry. Yeah, I've just typed in my email address. You can go ahead and email me your questions. And thanks so much, Pavan, for enlightening our audience on data migration. Uh, thanks very much. Thanks, everybody, for taking the time out on a Saturday to join our webinar. Uh, have a good night or good rest of the day. Pavan, any last words?
Yeah, thanks Reda for some opportunity, and the audience are so interactive, and I see the enthusiasm to know this data engineering stuff and data migration. So yeah, so please send your questions, sir. I think this PPT will be shared by Shraddha. I think you can go ahead and start your data migration journey. You can go to the exploration tasks and start exploring the data engineering and data migration things. Hope this helps you.
Great. Thanks again, Pavan. Thanks, everybody. Have a good night and a good rest of the day. And bye bye. Thank you.
Thank you. Bye bye.